today. We're going to be talking about choosing the right platform for your .NET UI application development, courtesy of Meshius. So before we get started, I'm going to let you know how I got to be here today. My name is Hunter Haaf. I'm a technical engagement engineer too at Meshius. I have a BS in computational biology from the University of Pittsburgh, and I also have a BA in nonfiction English writing from the University of Pittsburgh. I started at Meshius in 2020, March, and I'm currently studying for my master's in cybersecurity at NYU. So let's get right into it. First thing that I want to talk about is here we have a quick timeline of the different .NET frameworks and where the various technologies once stood and now where they stand today. The key thing that I want you to think about as we go through this is how all of these different technologies, .NET Framework, .NET Core, web technologies, and mobile are now all under one umbrella referred to as simply .NET. So there's this great unification that Microsoft is going for to try to bring everything together and make it easier for developers to do their job. So in 2002, .NET Framework 1.0 was released. This was the first .NET Framework released, and .NET Framework, as some of you may know, it's primarily for native Windows applications, desktop applications, and can be used for web services as well. 3 years later, Microsoft released .NET Framework 2.0, 2005, and then again 2006, 3.0, and then you can see 3.5 the next year, and then 4.0 in 2010. And then they stayed on the 4 all the way up until 2019 with the last release of .NET 4.8, and that will be the last major .NET framework to be released, as .NET 5 was released in 2020. So we'll get to that in just a moment. I want to take a second look at .NET Core. So .NET Core came out in 2016 with the 1.0 release, and the big advantage of .NET Core is that it can be used natively on any operating system. So if you were to run a .NET Framework application on an operating system other than Windows, and sometimes even on Windows itself, if you didn't have the .NET Framework downloaded, you would have to download it and install it and make sure that it could work on that operating system. Now, this would be a problem if you're trying to run your application on a Mac or Linux machine. So thus came .NET Core, which now can be natively used on any operating system, not just Windows. So as we move along, .NET Core and .NET Framework eventually merged together with the .NET 5 release in 2020. And from then on out, we are now just at .NET 6, .NET 7, and this year .NET 8 is going to be released in, I believe, just a couple months. So we'll move right along. For web development in 2016, the big jump for web development is the first ASP.NET Core was released in 2016. Now, this had a similar approach to .NET Core, except in the web field, where now you can run a web application natively in any operating system. And that, again, got merged all together in 2020 under .NET 5. And then lastly, we have Mono for mobile development, which is for Android and iOS. So in 2011, Xamarin 1.0 was released. In 2013, Xamarin had integration with Visual Studio, and then we had Xamarin 3.0 in 2014, with Xamarin Forms also released. In 2016, Microsoft actually acquired Xamarin, so originally it was an independent company. And that finally got merged with .NET as well in 2022 under .NET 7 when .NET MAUI was released. So that's a quick summary of where we were, how we got here. Now let's jump right into desktop technologies here. So I've broken this presentation down into 3 main sections: desktop, web, and mobile. And since one of the first questions you're going to ask yourself when you're making your application is, am I going to be doing it for the desktop, for the web, or mobile device? I figure this would be a proper way to break it down. So you'll see here that we have a bunch of different development environments, and I'll start with W. I know it might be confusing, but don't worry, we're going to expand on each of these in a moment here. So the first one, and probably the most famous of all these platforms, is WinForms. It came out in 2002. Some of you may be familiar with this. It's personally my favorite to develop in, but the design layout is based on forms and controls, makes it much simpler to use, and it's mainly for basic UI design. So WinForms uses the Windows API to render components on the screen. This also means that it's limited by the capabilities of the Windows API. It also requires additional libraries or plugins to support multimedia content such as .mp3, mp4, or animations. Newer versions of WinForms are based on the .NET Core, like we discussed, .NET 5, .NET 6, etc., and as such, they're much more lightweight. It means they have more flexibility when it comes to implementation in different operating systems or environments. It's also one of the easiest environments to develop in, thanks to the rich design time experience Visual Studio offers. And lastly, WinForms can also be used through third-party libraries such as Mono if you wanted to develop on non-Windows operating systems and you're using a .NET Framework version of WinForms. That would be typically out of style now that we have moved to .NET 5 and above. So here we're going to look at just the basic. This is a screenshot of a blank, fresh Windows application. Looking at this, it looks like a standard application you see on a Windows machine. You have the minimize, expand, close the application, the name of the form, and then here you put all the good stuff. So where does the good stuff come from? Well, in WinForms, you can design straight from the toolbox over on the left-hand side. You can just open up the toolbox, drag and drop grids, controls, whatever you'd like, drop it right on the form. And what's really cool about this, you see how there's little marks here. You could actually expand this inside of the application if you wanted to make your form bigger or smaller. And you can see it's very user-friendly for the developer in terms of trying to manipulate how this form looks. Down here, we also have a properties window where you can quickly set each of these things like the back color, the fonts, font color, all these things you can control right here on your form without even having to touch the code. And on the right, you can see your full solution explorer, your project, and each of the different parts and how they work together. So this is all pretty cool, pretty simple, and it's Microsoft's first step into the development experience for developers in Visual Studio, and they still develop it today. So next, we're going to look at WPF, which stands for Windows Presentation Foundation. WPF uses DirectX to render everything you see on the screen, and that means that WPF can use hardware acceleration, which is provided by DirectX. That leads to faster, more responsive UIs, and it allows for more control over how your application will actually be able to display whatever you'd like to show. The design layout is based on XAML, which is a markup language that's similar to HTML. It allows more customization, flexibility to design, but it's harder to use simply because you have to learn another language, be able to read XAML. Skipped ahead. All right, so it natively supports multimedia content such as audio, video, and animation support. It's great for interactive presentations or applications that require embedded videos. Similarly to WinForms, WPF can be used through third-party libraries like Mono on other non-Windows operating systems if you're developing pre.NET 5. It also supports vector graphics, which allows UI elements to scale up or down without losing quality, and that's good for high-resolution displays if you're going to make an application to be shown on a 1440p or 4K monitor. You can do so very well with WPF without losing quality. So overall, WPF offers more customization than WinForms, but it can be more complicated to implement due to having to use XAML in addition to just pure C# or VB.NET, and you can't necessarily manage everything through the designer like you can in WinForms. So let's take a quick look at what this looks like. You'll see it's very similar to how a WinForms application is set up. The only difference is down here we have this XAML window. On the right, the properties window is a little bit strange too. If you were to manipulate any of these properties in here directly, it would also change in the properties window and vice versa. It would change in the XAML. So it is down here, the XAML, very similar to HTML. And it's up to you how you'd like to really change it. And you'll notice over here in the Solution Explorer, we have some different file extensions for our project files, such as .xaml files. But overall, the general flow is similar to how a WinForms application is set up. There's also a toolbox on the side where you can simply drag and drop controls on the designer, just like in WinForms, except due to the XAML markup, you'll have more control over how these aspects will appear in your final application. Because let's say you were to drop a grid on here, you'll notice down here there's this grid. It would show up with more properties that you can edit all right in here in the XAML. And that happens automatically when you drag and drop. All right. So now I want to introduce you to something called WinRT. It's known as Windows Runtime. This was developed in 2015. It's still developed today. So this is more of a system service rather than a potential application development environment, but it plays a key part in the world of application development within .NET. So this was initially released for Windows 8 and Windows Server 2012. WinRT is a language-independent application binary interface based on the COM data service. It allows modern Windows APIs to be consumed from multiple languages. So it's originally implemented for C++ applications, but it's also supported in not just C++, but Rust WinRT, Python WinRT, JavaScript, TypeScript, C#, and VB.NET. So the main purpose of this is that it's able to use any Windows runtime class as if it were a standard part of the underlying framework. So this is most commonly used when you're developing C++ applications. It's not very common outside of the specific scope of C++ application development, but it is possible to, let's say, use a Windows runtime class in Rust or Python or JavaScript and TypeScript through the use of WinRT. Overall, this isn't really a popular choice anymore, but it still has some uses if there's a portion of the Windows API you need to access within your applications. Next up, we have UWP. This is one of the latest and greatest development environments from Microsoft. It's known as Universal Windows Platform, also developed in 2015. So what all these past platforms have been leading towards is a universal implementation of code that is simply written once, but can be used in multiple places. The goal brings us to UWP, or the Universal Windows Platform. It's introduced with Windows 10. This is also XAML-based, similar to WPF, so you have increased flexibility in design choices. It's useful for creating any Windows-specific cross-platform universal application. So that means you can make an application for the PC, for HoloLens, Xbox, Surface Hub, or an Internet of Things device. Applications in UWP are built in typically C#, VB.NET, JavaScript, or C++. The UWP API itself is actually implemented in C++. And interesting thing about this is if you want your application to be hosted inside the Microsoft Store, it has to either be a UWP or a WinUI application. WinForms and WPF applications cannot be deployed in the Microsoft Store. UWP has different initial layout options that allow you to choose which UI elements you want to develop for, such as if you're creating an application for a tablet, keyboard and mouse, Xbox controllers, etc. And also a limitation is that you cannot run a UWP application on earlier versions of Windows, which would be anything that came before Windows 10. So in order for your application to work, it must be used on Windows 10 and up. And this limitation is also one of the reasons why it's able to be on the Microsoft Store, because it's more secure in that way. So here you'll see a typical UWP design interface. You'll notice it's very similar to WPF in that we have the XAML window. Down in the properties looks similar. The Solution Explorer has different file extensions for the different applications that this may run on. And on up here, you'll notice that we can actually choose what we want our form to look like. If we're going to maybe say we want it on a Surface Book, do we want to see it on the phone? We want to see it on the desktop? What are we actually making this for? And you can choose that here and then start designing right there. So if you're going to deploy your application in multiple locations, you could choose it all in here and test it one at a time, make sure everything looks good to go while only writing your code once. So very cool. Next, we have WinUI, and this is the Windows UI library, first made in 2011 and still developed today. This is the native user experience framework for Windows Desktop and UWP applications. Again, it's XAML-based, something we won't escape. And in other words, it's a user interface API that enables the declaration of user interfaces through the use of XAML markup language. So you can create new apps from scratch right in WinUI, or you can migrate your existing MFC or Microsoft Foundation class projects, WinForms, or WPF applications all into WinUI. WinUI projects can be written in C++, C#, Visual Basic, or JavaScript if you're using React Native for Windows. There's actually two types of WinUI that are out right now. There's WinUI 2, which was created for UWP applications, and then we have WinUI 3, which is actually created for Windows as a more general approach. There are some key differences between the two. I'm not going to go into that here, but if it interests you, definitely check it out. The main purpose of WinUI is to create a user interface for UWP applications through the use of XAML, and it joins HTML5 and DirectX as one of the 3 UI frameworks built into the Windows runtime. Now, the main goal of WinUI, much like UWP, is that you can write your code once and deploy it everywhere. In this way, it's made so that you can create your interface once and then deploy it everywhere. Now, currently, there's no designer view available for WinUI, and that is a major pain point for many developers because they can't preview their work before deploying it, which leads to longer debugging sessions because you have to build your whole application before you can actually see what your code that you've written looks like. So that is a pain point, but hopefully in the future, Microsoft adds a design view for WinUI as well. Now, I want to recap how the latest technologies Microsoft has released have aimed to form this concept of a universal application development, which is where code is written once and deployed in many places. WinRT came first and was a way to introduce the Windows API into different programming languages as if it was natively there. Then we have UWP, which is a way to write your code once and then deploy that code across various Microsoft platforms. And finally, we have WinUI, which is a way to create a single user interface, or in other words, you only have to write your code once, and that will then be deployed across various formats, such as a desktop or tablet. Okay, so you might be asking yourself, what questions would I ask myself if I were to be developing a new application for the desktop? The first question you'd want to ask yourself is, do you want your application to be on the Microsoft Store, or do you want to create an application for multiple different Microsoft platforms? If the answer is yes, then you're going to want to go with WinUI or UWP, as these are the only options for being able to deploy your application on the Microsoft Store, and they allow you to create multiple different applications from writing your code once that could be deployed across various environments. If not, you don't care about any of that, that's fine. The next question you're going to want to ask yourself is, do you need an advanced desktop application with embedded media and enhanced stylistic control options? If so, you're going to want to check out WPF. If not, simple is fine. Then you're going to want to go with WinForms as a choice for you. Now, we're going to take a quick break here to check out WinForms and WPF sample applications, just so you can see what they actually look like. 1 second. Okay, so right here, you'll notice this is actually one of our samples that our developers made that I just downloaded to showcase real quick. In here, we have different components. If I were to click in here, we see that we have our flex grid right here that I clicked on. As soon as I clicked on it, you can see all the different properties that are displayed. We can go down and change some of these properties right in here. You can also quickly click on this and see all the different components here. There's a lot to go through, so I'm not going to click on everything, but the main form is actually, should be the entire form that we see right here. Be able to change the size of it. And if we go to our toolbox, we can actually drag and drop standard Microsoft controls directly into this. Show how easy it is. Now we have a button called button 1. Let's say I wanted to see the code behind. I could right click this, and it takes me right to our application logic. It could be held right in here. Very cool stuff. We want to go back in our Solution Explorer. We can just right click, go back to the designer. And let's say I wanted to see what happens if I click this button. Well, if I double click this, it'll immediately create an event for me. That would happen if I were to fire the button 1. I can write my code in here for however after I click it. So it's very cool, very simple to use. And one thing that I like to mention is this designer CS file. We can open this. This is actually automated. This is all behind the scenes. I'm manipulating that form there. This will actually change. So typically in WinForms, you don't manipulate this yourself. it's kind of abstracted from you, but you can see the code here when you're actually going through and manipulating things. This is different from WPF projects, which I'm going to show you right now. So to contrast that, here is a WebF application, another sample that we have here. And you'll notice down here, we have all the properties. This is actually the equivalent of that designer CS file that we saw, except it's now in XAML format right in front of us. Let's say we wanted to change the column header background from black. Let's say we want to make it red. Type in red right here. What's really cool about this is that we can see our changes live in the actual designer. So this leads for obviously quick debugging. We don't have to build our application every time just to see how it would look. It saves the developer a lot of time, and it's overall pretty cool. Here you can see, like, if I were to quickly change the width of this form, I just add a 0. It's going to go quite bigger. So you can really get to the nitty gritty and mix it up however you'd like right in here. Also, it's exactly the same in terms of you can look at the code behind to see the application logic and WinForms, but different control. So all cool, interesting stuff. Also has a toolbox, drop controls right onto the form, and that'll just add it directly to the XAML markup, which I'll show you right here. When this flex grid that was added, so you have the main window, which we changed. You can see how it expanded, but then we have the grid, and you can see all the properties of the grid that you can manipulate in here. And if I were to actually go over in the properties window and change some of these grid settings, anything I click in here, it's smart enough that it can change over here in the properties window as well. So the ease of use is there, and it is quite nice. Looks like Visual Studio doesn't like it though, so keep going, chugging along here. So here we go. Next, we're going to talk about web development, and you'll see we have we're going to go through WebForms, Silverlight, MVC, ASP.NET Core, and Blazor. So typically, this is the first thing that people will talk about. We still see it today, but it is no longer officially being developed by Microsoft, and the support for it is fading. But a lot of people like it. They cling to it because of the ease of use, and it's what they know. It's familiar. It's ASP.NET WebForms. So these are typically written in C# or VB.NET. It came out the same time as WinForms, so it's Microsoft's approach to WinForms on the web. So it's very similar, designer-friendly, as we just saw. This can actually be written in any language that supports common language runtime, but it's typically C# or VB.NET. It lacks cross-platform support, and it is not open source. It's proprietary. It's closed, so it does not have open source support either. It's comprised of server controls and view states. Server controls are reusable components that render HTML markup and respond to events, and the view states are used to persist the state of the server controls between the stateless HTTP requests sent and received from the client. Now, this uses a code behind model to separate the design markup from the programming logic. It has .aspx, which is HTML or other markup, which is separate from the .aspx.cs, which contains the programming logic C# files. It's typically hosted by a web server and accessed via stateless HTTP protocol. Now, state management for this has to be implemented by the developer. This means that it's up to the developer to properly implement changes when events are fired on the web page, picked up by the server, and then served back to the client's machine with the proper response on the web page. This is typically considered outdated when you compare it to modern web technologies, as it's no longer being developed by Microsoft, and it's only supported in the .NET framework. And as we know, we're now into .NET, so this is not coming along with us, unfortunately. Here's an example of what some WebForms applications would look like. So in a perfect world, your ASP.NET WebForms application would look similar to the bottom image. You can see that there's even a designer view, which is similar to the WinForms, and some HTML code is above it, shown in the open default ASP.x file. But the reality is that most of the applications don't look like this. They look closer to this guy on the top right, which is kind of outdated. Microsoft Explorer kind of gives it away. So moving along, we have Microsoft Silverlight. Now, this was a way of Microsoft to implement C# applications into the web. It was a browser plugin similar to Flash. This is downloaded as a single package on the user's machine via their web browser. It was very successful for a few years with .NET users, as web is a challenging environment for application creation, and plugins like Flash were very popular. Security concerns did arise, and as more secure approaches such as WebAssembly and HTML became the norm, most modern browsers no longer support the implementation of plugin applications like Silverlight or Flash. So, in fact, this actually only works in Internet Explorer, which itself is outdated and no longer in service. One of the major proverbial nails in the coffin for this technology is that around the same time when iPhones and iPads took over the mobile market, Apple decided that plugins would no longer be supported on the iPad, which pretty much killed the market for Silverlight and marked the beginning of the end of its development cycle. Here's real quick what a browser plugin for a pop-out calendar would look like. You can see the XAML above, which is a common theme, and similarly to other design views, there's a properties window beneath the Solution Explorer. All right, so next, this is a big change for Microsoft, and this is ASP.NET MVC, and that marks a big step away from the proprietary closed garden approach of the ASP.NET WebForms, as MVC is open source. And it's also the first to implement the model view controller pattern. So the model is the business layer that represents the state of a particular aspect in the application. The view is the display layer. It accepts info from the controller and renders to the user interface to display that info. The controller is the input control layer, and that handles interactions and updates in response to the changes in the application state. Now, this approach is considered lightweight because of how it breaks down a complex problem into those three moving pieces, the model view controller. And typically, this platform would be picked for development due to breaking down the complex problem of web application development into a digestible MVC format. It does not use view state or server-based forms, and that differs itself from the ASP.NET WebForms. But as all good things must come to an end, ASP.NET MVC is no longer in active development. Which brings us to ASP.NET Core. ASP.NET Core is simply the cross-platform version of ASP.NET MVC with some major improvements, as this is Microsoft's chance to reimagine their web framework in a more universal light. It came out 9 years after ASP.NET MVC, and now the MVC ASP.NET Core applications can run on Windows, Linux, or Mac OS. There's no compilation required, as compilation is continuous. It has a modular framework, which is distributed as NuGet packages, which we'll cover later, meaning the packages required for the application can be individually managed via NuGet. It's optimized for cloud runtime, meaning these applications are made to run well via the internet. It has a unified development for web UI and web APIs, which ties the app logic and app design together in one space. And it's lightweight for the same reasons as ASP.NET MVC was due to the model view controller architecture. Also, like MVC, it's an open source. It has built-in support for dependency injection, which allows developers to decouple different pieces of their application, which is good for abstraction and reusing pieces of code in various places. So here, I wanted to showcase the design environment of ASP.NET Core MVC, as this continues the use of the MVC design pattern introduced with the original ASP.NET MVC, but now it allows it to be used across various operating systems natively rather than solely on Windows machines. On this particular page that we're looking at, we're seeing the default controller for a brand new ASP.NET Core web application. The controller handles the events that occur when a user interacts with a view and sends that event back to the model that will then handle the logic to be implemented and sent back up to the view rendered on the client's web page. So this is what actually handles if you click a button on the page, this sends it, the back end handles that logic, passes it back up, right back to the client, so the changes are reflected on their web page. Next, the latest web technology released by Microsoft and their new baby, some might say, for web development is Blazor. This is an open source framework which allows developers to create web applications using only C# and HTML. And you also have the option to use CSS or JavaScript interoperability if desired. This is huge for developers because it means you don't necessarily have to use JavaScript to develop your applications. You can just continue to use C#, which you're familiar with, and HTML, which you have a taste of if you've done any XAML development, as HTML is just a markup language similar to XAML. So two main flavors to choose from of Blazor. There are more, but one is Blazor Server. This is the most popular, and the processing load is done on the server, presumably hosted by the developer. The client's web browser downloads a small page and updates its UI over SignalR connections. So this allows the server code to send asynchronous updates to the client-side web applications, and each client connection to the server starts a new SignalR connection managed by the server. This means that if 3,000 individuals are trying to connect to your website concurrently, your server will have to spin up and manage 3,000 SignalR connections. It shouldn't be a problem, but scaling can be an issue, theoretically, depending on the size of your application. One note I'd want to mention on that is typically a single machine could sustain up to 20,000 SignalR connections concurrently. How many times are you going to have 20,000 users actively creating SignalR connections? Typically not much, but it could exist. And if you needed to scale up, you could just add more machines or offload it to an Azure SignalR third-party service. So a big advantage to Blazor Server that I want to mention also is you can keep your code logic private, as all your code is held on your server away from the client. The simplest version of Blazor to use and implement is Blazor Server, and therefore it does have a lot of popularity. The other one I would like to mention is Blazor WebAssembly. Now, this separates itself from Blazor Server because the processing load is entirely done on the client's hardware, leading to a slower initial app launch speed as the entire application is downloaded onto the client's machine via their browser. But once it's downloaded, you have faster response times for page processing because all of that is handled on the client's machine directly. So a single page app is downloaded to the client's web browser before it runs. That means that if we take our previous example, if 3,000 people want to have access to the web page, it'll have no impact on performance as there are no direct connections managed by the server. Instead, the entire application is processed on the user's own hardware, meaning scaling should not be an issue when it comes to the number of users. However, this can be harder to implement because you need an API layer typically to obscure some of your secrets from the user, because all your C# code would otherwise be on the client's machine. But an added feature is that once the application is downloaded, it can be used in an offline environment if no calls have to be made back to a server and then update the page via the internet. But again, one of the disadvantages is that since the application is downloaded on the client's machine, the client can view the C# source code that it was written within the application. So you wouldn't want to expose any connection strings or secrets, private keys within your application if you deploy it as a WebAssembly app. Instead, you'll want to create that middle API layer, which abstracts calls to your database. For example, if your application requires connection strings or other secret information. Now, in total, there's 6 flavors of Blazor. Some are not officially released yet. The other ones I'll mention quickly is we have Blazor Progressive Web Apps, Blazor Hybrid, Blazor Native, and Blazor United. So really those can be broken down into 3 main types. We have Blazor Server, Blazor WebAssembly, and Blazor Hybrid. Now, Blazor Hybrid's main focus is to blend desktop and mobile native client frameworks together with .NET and Blazor, which is going to become more popular in the future as we move ahead. So this screenshot demonstrates the sample default Blazor application template given to you within Visual Studio when you first create a new Blazor application. As you can see, the values shown are generated randomly and presented for example uses only. But in the code behind, you can see that the C# code is prefaced with the @ symbol right down here. And that's on line 24, where a for each loop is created that iterates through the forecast array. It creates this random data that we see. Above it, we can see the HTML code that's generating the column headers on the table. So we have the date, temp again, Fahrenheit, summary, and that's all displayed right here through this HTML. So Blazor really allows you to just use HTML and C# to make a web application, no JavaScript required. Very cool. Now we're going back to our questions. If you're choosing the right platform for web, you have to ask yourself, do you like using JavaScript and various web technologies for your web applications? Well, if the answer is yes, you're going to want to check out ASP.NET Core MVC. If not, you want to keep it C# and simple, then the question is, do you have any plans on having your website viewed offline and or by hundreds of thousands of users at one time? If yes, you're going to need to go with Blazor WebAssembly or Blazor Hybrid so that it doesn't become much of an issue for you. You don't need to manage all those SignalR connections. If not, you're going to want to go with Blazor Server, and 99% of Blazor users will go with Server. Now, that's not a real number. That's just in my experience. Most people that I've talked with tend to lean towards Blazor Server. Some disclaimers at the bottom. Now, we're going to take a break here real quick and check out this Blazor application I'll just show you. So over here, you can see Blazor has a lot of different parts to it. We have the client, the server, and then shared portions of a project here in the Solution Explorer. Under the pages, so this is one of our samples again that I've downloaded. And you can see that each of the pages that would be on our web page are actually going to be shown here in Razor format. These are Razor pages. This is typically how Blazor handles everything that's rendered on the screen. The main meat and potatoes is going to be in here. So let's see if I can open up this self-freezing.razor. In here, you can see we have these @using statements at the top and the name of the page. This would be the URL that you would actually go to. You can see that we have the headers for HTML, the description that's going to be thrown in. This is all taken from our app resources, so you can store these in another file down here. Depending on localization as well, you could do so if you needed to have it in different languages. This allows you to dynamically kind of load in, whether it's in Spanish, English, or any language of your choice. Then we also have the properties listed here for the actual, this is just for our control, but if you were to use a Blazor control, you could have the properties listed above it and set these properties in here, choosing the item source, etc. And then down you actually have your code block, which allows you to, for here, we just create an observable collection of type customer. We call it customers. Then we set these customers to load in a list of 100 customers when we initialize the form. So very simple. All of it's abstracted in other places within the application. But just so you can see, this is essentially how it would be handled. We also have our app settings.json here, and this would actually have all of our typically sometimes it has like your connection strings or other sensitive information that you could have here. This you would not have in a Blazor WebAssembly application. So this is a Blazor server application that you're seeing here. A WebAssembly application, you wouldn't want to share this with the client. You'd keep it abstracted in that middle API layer along with other secrets or connection strings. But nevertheless, this is the basic rundown of it. And it's very interesting. There's a lot to it. I don't want to take up all our time here going into it, but definitely check it out, especially if you're interested in web development. I'd recommend Blazor. So let's move right along to mobile. All right. So finally, we have the world of mobile development within .NET. It's quite a small world compared to the other platforms, but the most recent development platforms are perhaps some of the most exciting platforms offered by Microsoft to date. We're going to be taking a look at the Compact Framework, Windows Phone, Xamarin, and the newest contender to this space, .NET MAUI. So Compact Framework, this is a bit of a history lesson. It was released in 2002, and it's Microsoft's first foray into the world of mobile development. It was designed for personal digital assistants, mobile phones, and whatever else techies are using back then. As the name suggests, this is a compact version of .NET Framework library. There's some mobile-specific libraries included as well. Kind of interesting, but unsurprisingly, it's a legacy tech that's no longer in use. But these are actually interesting little applications here. Next, we have Windows Phone, and this is a discontinued mobile operating system developed for smartphones. It's created apps for Windows Phone 7, Windows Phone 8, Windows Phone 8.1, and Windows 10 Mobile. It's funny that it follows the same as their operating systems. Those are all operating systems for mobile devices. This was short-lived simply because it's outcompeted in the market, which goes to show that all big companies, even Microsoft, they flop a product or platform release from time to time. Still, it existed and just wanted to mention it. All right, so next is Xamarin. Now, this is a huge change, and it's a little bit interesting backstory as well. So this was originally an independent company that Microsoft purchased down the line in 2016. They started in 2011, so this is why it has kind of a strange name compared to everything else that seems like it has Windows in the name. It allowed .NET developer platforms to be expanded to build apps for Android, iOS, tvOS, watchOS, macOS, and eventually UWP, all through C# and Visual Studio. So the main advantage here is that developers can share existing C# code for use across many different device platforms. And due to Microsoft's struggles entering the mobile phone world with Windows Phone, this is a perfect solution to bridge that gap, as it allowed Microsoft to bring .NET into the mobile space and reach Android and iOS users, which is where 99% of the market was. So this has actually a component store to integrate with backend systems, third-party libraries, cloud services, and UI controls directly into mobile apps, which is a very nice feature to have. Xamarin Forms was introduced later on, I think in 2014, and that brought XAML, and it can also work with UWP. Now, the goal with Xamarin Forms was to implement the familiar WinForms and WPF-esque development patterns for mobile development. So we can bring more developers into the space, show them something that they're used to and comfortable working in. It allows you to write your code once and deploy it on different platforms. And the one thing about Xamarin is it outputs only to iOS, Android, or UWP. And the current plan by Microsoft is that Xamarin is going to be fully merged into .NET MAUI by May of 2024. So less than a year away. This will eventually just become .NET MAUI. Now, I wanted to show you a quick example of how this looks. So here we can see an iOS app development in Visual Studio on a Windows machine. It has a familiar looking interface, as we've seen in previous design view screenshots. You can see you have a toolbox. You have what looks like the phone in the middle of your design view. You want to see how your application actually looks, and you have your properties and solution explorer on top right. Now, if we go one over, here is the same exact thing, except now, interestingly enough, you can actually design this on a Mac as well. So we see the same application, except within Visual Studio for Mac. Xamarin.Forms is one of the original few platform options that natively work well when developing on an Apple machine. I just thought it'd be a nice quick comparison, showcases how Xamarin broached new borders by driving outside of Microsoft's traditional Windows-only playground. So now this is actually really exciting. We have .NET MAUI. So this is a cross-platform, single-target platform development environment. MAUI is basically the current iteration of Xamarin Forms. Xamarin has more flavors as a Xamarin Forms, iOS, Xamarin Android, but MAUI just has one, if we're going to ignore Blazor MAUI. But this still supports all the same platforms as Xamarin did, except now it adds native Mac OS support for form development to mobile development via the Mac Catalyst, compared to Xamarin Forms, which could only output to iOS, Android, or UWP. So now we have Mac OS support. We also have Linux support through Tizen. So this supports WinUI as the Windows output. If you're going to output your application to a Windows machine, it'll be in WinUI format. This is opposed to Xamarin, which only outputs to UWP. And there is a Blazor flavor of MAUI that embeds a web view control of the web application into the MAUI application components, and that would be Blazor MAUI, as mentioned earlier. So that would mean that with some tweaking, you can actually turn your web applications into mobile applications through Blazor MAUI. The goal of MAUI is that you can build your MAUI application once and then port it out and distribute it into the various supported environments. So while this is a great feature, the developer still must be aware of some of the design-specific requirements in the various platform deployments. such as the differences between Android and iOS development. When you build in MAUI, about 90 to 95% of your application will be the same across the various development options, but you'd still have to know that last little bit, the 5 to 10% differences between the different deployment environments in order to finish and properly deploy your application correctly. Still, it's very exciting and it reduces the workload by a lot. So let's ask ourselves some questions. The final decision tree for the mobile world. It's actually quite simple because the end answer is basically the same no matter how you slice it. So are you starting a new mobile application? If yes, we're going with MAUI. If not, do you plan on updating your existing mobile application in the future? If yes, you're going to migrate it to MAUI by May 2024. I mean, that would make sense as you're going to try to combine Xamarin into MAUI. If not, it's fine as is. You're going to just stick with your Xamarin, but you should probably migrate to MAUI as eventually the support and security updates will fade, and we're going to move towards the future, the better things. So you're most likely going to end up choosing MAUI if you're working on mobile development within .NET, as MAUI aims for one code base that can be distributed to all platforms. But this doesn't end here, because are you publishing for the web and mobile simultaneously? If not, you only want native mobile apps, you're going to go with MAUI. But if yes, you're going to choose MAUI Blazor Hybrid, because that'll save you a bunch of time as you're able to actually develop on the web and mobile simultaneously. It's really, really cool stuff. All right, so we're going to take a break real quick. I'm going to show you this MAUI application. So this is a brand new MAUI application. Rather than showing you a sample, I'm just going to show you what it looks like when you open it up straight from scratch. Right in here, we can see the different target frameworks that are listed. So this is actually going for .NET 7 Android, .NET 7 iOS, .NET 7 Mac Catalyst. Also, there's this target framework condition. So if we're building it and is the operating system platform Windows, then the target framework is going to be .NET 7 Windows 10. So you can see that this is a limitation that you need to have Windows 10. It's not similarly to UWP. It is not going to work if you try to build it on older versions of Windows. And right in here, you can see you can literally uncomment this. If you have a Tizen app and you want to work on Linux, you can install Tizen and follow the guide provided there. But here you can see all the different output types, everything that you would need in here, the images, the icon, the splash screen, all your resources are controlled directly right in here. And now we have this main page, XAML. So we're never going to escape XAML, but XAML is good because it gives us a lot of control over how we're actually going to design our application. If you view the code here, we can actually see the app logic. Now the starting app they give you is just a simple counter. When you run it, you click it, and the count goes up. If the count's 1, it says number of times clicked 1 time. If it's otherwise, it's 20 times, so it's very simple. Just shows you how some logic can be applied. And then when we go and view the markup, so instead of designer, it says view markup. We can see here how the page is actually going to look in the designer view. And then also up here, we can actually choose. So it says Windows machine, but if you wanted to, you have all your Android emulators. So I only have one, your iOS devices, and different deployment options here. I don't have everything downloaded here on my Windows machine, but if you did, they would all be shown. I just have this Pixel 5. But this, very cool. And if you run it, it actually will bring up a, let's say you do the Pixel 5, it'll phone. You can go ahead and take a screen, everything that you could do with the phone, all emulated on your computer. Just so if you have any functions that say take a screenshot, you can test your code and see if it works. Very cool stuff. I'm not going to run it because my computer will freeze. But that's okay. It's only because I have a poor laptop. Now let's finish up here. Last thing I want to talk about is how we can extend these platforms and add in new third-party controls to our applications. Now you could do this locally by just adding it directly in your references, or you could use NuGet. Now NuGet is the best approach in my opinion because NuGet is Microsoft's packet manager integrated into Visual Studio. It allows for easy third-party reference management and version control per project within your solution. NuGet packages contain compiled DLL code and are uploaded to NuGet.org by the developer of the compiled code themselves, and they're approved by Microsoft. Now, this can add time-saving features because you can download a third-party references in your application, so you don't have to necessarily, reinvent the wheel. You can use someone else's wheel. NuGet doesn't require the file to locally exist on your machine to add the reference, because you can just download it from NuGet itself within Visual Studio. And then the NuGet package authors decide their own licensing agreements for their own packages, whether the package itself is going to be requiring a paid license or if it's open source. That's all decided by the package authors themselves. Microsoft does not control that. So here we can see a screenshot of the NuGet package manager within Visual Studio. There's a search. You can search for and select your package and straight from NuGet.org, but you can change where the package source you're searching for is coming from up here. When you find a package and you select one, you can see then on the right-hand side after selecting it, you can choose the version that you want to go with. This drop down would show you all the other previous releases. Let's say some of your dependencies require you to be on a lower version than the latest. That's fine. You can actually control that right in here. It also lets you quickly install it or uninstall it. And you can also see all the various information related to the package, including the date it was published, the number of downloads it has, the author. So a bunch of cool stuff. It kind of adds some legitimacy and lets you know you're getting the right thing. And you can always dive in for more if it interests you. So with that, I'm going to open the floor to some questions. And I also have the ComponentOne product manager with me here today, Greg, who's going to help me read the chat and answer any questions that we may have regarding any of the topics that we discussed. So thank you all for sticking with me and going through that. I hope you learned something. Have at it.
Hey, Hunter, thank you for the comprehensive history of .NET and helping us compare and contrast.
My pleasure. Thanks, Greg.
Why don't we talk about ComponentOne too while we
Sure thing.
questions?
All right, so these last two slides here just give everyone a history of us. So the product that I work on is ComponentOne, and we have controls for all the platforms that were presented here. For desktop, that's WinForms, WPF, WinUI, UWP. For the web, we have Blazor controls, ASP.NET MVC controls, ASP.NET Core. We even have WebForms controls, Web API. For the mobile, we also have Xamarin and MAUI. We also have a great support team that's ready to help you and utilize our controls to their fullest potential. I'm a little biased. I might be on it, but all the samples shown today can be found on our GitHub. And we also have a direct link there at the bottom, right to our website, but you can find it on Google quite easily. And lastly, overview of the company. We don't just have .NET UI controls, which is ComponentOne. We have a bunch of other products that may interest you. We have a bunch of JavaScript UI controls under Wijmo. It's very similar to the .NET UI controls, just in JavaScript format. You can use it in React, Vue, Angular, pure JavaScript. We have spreadsheet solutions for .NET and JavaScript, and that, again, all of these are going to be React, Vue, Angular, pure JS. You can use it in all of them. We have reporting solutions for .NET and JavaScript under Active Reports. We also have document APIs for generation and manipulation solutions for Word, Excel, PDF, and images, which is our documents product. So this would actually be if you wanted to generate a PDF document through code programmatically, you could do so, or even edit PDF documents that are existing. You can do so through code. Very cool stuff. We also have JavaScript data presentation and data grid platform, which is known as data views. And you can learn more all about this at our website. So check us out. If there's anything there that interests you, be used for you or your development team, we're happy to help.
Yeah, I guess last call for questions. We have no questions
Yeah.
yet. All right, I think you can wrap it up, Hunter.
All right. Well, thank you everyone for joining us today. It was a pleasure sharing all that information with you, and I hope everyone got something out of it. If you have any questions, feel free to reach out. I think my email address is on the first slide, so it'll be a recording of this. Check it out if there's anything that you want to rewatch or learn more about. Hope everyone has a great day, and thank you for coming, and take care.